So the topic will be, for today the topic will be the overlapping generation model. The overlapping generation model, which was given by Professor Diamond. And okay, so this overlapping generation model that we are going to do, and we are also we are going to observe the income effect and substitution effect within this overlapping generation model. So basically this overlapping generation model, which I am going to talk about here, it was given by, the idea of this overlapping generation model is given by Professor Diamond, or we can say that it was propounded by Professor Diamond. Now what does it tell actually? So in this model we say that there is a turnover. Professor Diamond has said in this model that there is a turnover of population. What do you mean by turnover of population? Turnover of population means individuals are continuously born and they are getting old and dying, but two generations are overlapping in the market. Suppose there is an individual, and that individual starting to work at 18 years of age, from 18 years of age. When that individual is 48, okay, suppose his son was born in when his age was almost 22. So when his age is 48, his son is probably 26 years old, and they both are working in the market. He being 48 years old, and his son being 26 years old, both are working in the market. So basically in this type of situations there is a overlapping of generations. The earlier generation and the next generation both are working in the same market. So there is a overlapping of the generation in the market. Now so the basically I want to tell here that two generations are overlapping in the market. That is the basic fundamental thing about this model, that two generations are overlapping in the model, are overlapping in the market. Now if we assume, let me establish this model. So if we assume discrete time phase with two period, we are assuming discrete time phase, not a continuous time phase. We are assuming a discrete time phase with two period. So basically here these two period are not year 1 and year 2. There two periods are basically the present period and future period. We have to take it as in this form, that these two periods are not like the present period and I mean year 1 and year 2, or year 3 and year 4. It is not like that. These two periods are basically current generation and future generation. So that are the two periods here, current generation and future generation. See, if we take two period and if we consider two period, and suppose we have a labor force at time individual t. Now what will be the labor force at individual t at a time period t? Labor force, or you can say individual, both you can say. So what will be labor force at period t? So if we want to know the value of labor force at period t, now it will be obviously a fraction or a proportion of the labor force at period t minus 1, and we have to multiply it by 1 plus n. Here n is basically the population growth rate. So suppose the labor force at t minus 1 period is consisting of 200 labors. Now obviously the population will grow, or the labor force will grow. So we are taking that growth rate as n, and we are multiplying this previous labor force or labor force of the previous time period with 1 plus n, so that we are getting the labor force of the current period or present period. Now so if I take this form and if I divide this, if I put this lt minus 1 in the left hand side, then what happens? Then we get lt by sorry, I am making a mistake here. I want to actually take this 1 plus n in the left hand side. Then what happens? Then lt by 1 plus n becomes equals to lt minus 1. So here this is the amount of labor force in the previous period. If I want to say that what is the amount of labor force in the previous period, then this is the amount of labor force in the previous period, that is obviously lt by 1 plus n. You can also say it is, you can say it labor force in previous period, or you can also say individuals in previous period. In previous period, or you can also say individuals of previous period, that is also okay. In previous period, it is also same for the previous one. You can say it labor force at period t or individuals at period t. Now we are taking the consideration of consumption of period 1 and consumption of period 2. So I mean here 1 and 2 are nothing but it is not basically the year 1 and year 2. Here 1 and 2 are basically the consumption in current generation or the consumption when the person is young, and another one is the consumption when the person is old. So here I am taking two consumptions, C1T, which is denoting consumption by person T, by person consumption by the person at period T, and obviously in that time period the person was young. We are assuming that the person was young in that time period, at period T when the person is young. And consumption in period T, obviously here it is, we are assuming it 2t plus 1 suppose. So this is also consumption in period T. We can say it consumption in period 2t or t plus 1, you can say it. Here you can say it 1t, that is also right if you say this. Consumption by person at period 1t when the person is young, and consumption by consumption in period 2t plus 1. 2t plus 1 is nothing but a time period when the person is getting old or when the person has actually become old. So when the person is old. So when the person is old, then that is the consumption is that phase's consumption is denoted as C2 plus 1, and then the consumption when the person is young, the consumption of that period is considered as C1T. Now if we want to write the utility of the individual who is born at period T, then how can I write it? Utility of the individual born at period T. Okay, now utility is basically the consumption in both the periods. By that we can write out the utility function. So utility will be consumption in first period, consumption in second period, second period or the future period, and the future period has to be discounted because we don't know the amount of consumption in the future period, so you have to discount it, and we are discounting it by 1 plus rho, where rho is the subjective discount rate. It is the subjective discount rate. I am not writing it entirely here. It is the subjective discount rate, and this will be written as C to the C1t to the power 1 minus theta divided by 1 minus theta, and it will be also be to the power 1 minus theta divided by 1 minus theta. So this is our utility function, Here theta is greater than 0 and rho is obviously greater than -1. So in this case, if rho is greater than 0, then we are actually giving greater priority in the first period. You can see it. If rho is greater than 0, then in the first period, the value of the first period will be, I mean to say, this denominator of the second portion or second period, this denominator will be bigger if rho is greater than 0. So this entire fraction will be smaller. So we are giving much more importance to the first period when rho is greater than 0. And when rho is smaller than 0, then this fraction becomes smaller, this entire this denominator becomes smaller, this entire fraction becomes greater, and we are giving greater importance or greater priority to the second period. So that's how we can do it. So let me write it here. This is the form of utility function that I have represented here. This is the form of utility function c1t to the power 1 minus theta divided by 1 minus theta, and c2t plus 1 into the power 1 minus theta divided by 1 minus theta, and it is being discounted by a subjective discount rate called 1 by 1 to, plus rho, and rho is the subjective rate of discount. So the concept is here, if let me write that also, that if rho is greater than 0, first period is given the priority. First period has obtained the priority. And if rho is less than 0, then second period has obtained the priority. So basically now we have to write the production function. Production function can be written as yt. We all know how can we actually write the production function. In economics, we write production function is a function of capital and labor. We all know it. Now here we have to include the time with capital and labor. So we are just giving it KT and LT. Now this labor is not just labor. This is basically the technologically efficient labor force. So for that we have to multiply this labor with technology. And technology or current technology can be denoted as AT. We are denoting as AT, and we are multiplying this technology AT with the labor force. So now the labor force become technologically efficient labor force. So if I want to write down the current technology and previous technology in a relation, then I can write it as suppose AT, it is a current technology, is obviously equal to previous technology, but we have to multiply it by the growth of the technology. The previous year's technology and the current year's technology will not be same, it will grow. The previous year's technology, the technology in the previous year will obviously grow. So it will grow at a rate of g. So g is the growth rate of technology, and by multiplying the previous year's technology with 1 plus g, we are getting the current year's technology, that is AT. So this is growth rate of tech or growth rate of technology. Now the concept is here. We all know that we have some another functions. So suppose the total income of a person. Young person divide the total income into two parts. And if we assume that the income of a person is basically the wage that he is getting and the technology that is working upon it. So WT into AT is the income that the person is getting. Okay, so WT and WT multiplied by AT is the income that a person is getting, and it divides, or the person divides this income into two parts. He can consume it or he can save it. Right. So if I want to write the second phase consumption, how can I write the second phase consumption? Let us see now. Second phase consumption. So the second phase consumption is nothing but C2T plus 1, and it will be equal to a portion. Second phase consumption will be equal to a portion of the saving from the first period. That means suppose in the first period my income was 10 rupees and I consumed 8 rupees. So I have 2 rupee remaining in my bank account, and that 2 rupees will be consumed by me in the second phase. So second phase consumption is nothing but the savings of the first period. So the savings of the first period can be written as total income of the first period, that is WT80. That was the total income in the first period, minus consumption in the first period, that is C1T. We all know total income minus consumption is saving. So that will be my consumption in the second period. But we are not sure about the consumption of the second period. So we have to discount it. And we will discount it by 1 plus R to the power RT plus 1. Here RT plus 1 is basically the rate of discount by which we are discounting the consumption of the second period. Now, if we divide this equation, if we divide this previous equation with respect to, or if we divide this entire equation by 1 plus RT plus 1, what happens? So if we divide this equation, it becomes C2T plus 1 divided by 1 plus RT plus 1 equals to, and in this part we have 1 plus RT plus 1 here, and we are dividing the equation. We are dividing both the sides by 1 plus RT plus 1 into obviously WT AT minus CT. So this part and this part will be opted out. We have only remaining now C2T plus 1 divided by 1 plus R to T plus 1 equals to WT AT minus CT. So this is what we have now. Now second period consumption is basically, it is actually telling that we have actually discussed all about it. Now this part, if I just take the CT on the left hand side, now this will become C2T plus 1 divided by 1 plus R to the power RT plus 1 plus C1T, that is the first period consumption, this is the second period consumption, this is the second period consumption, this is the first period consumption, equals to lifetime labor income. Obviously the labor income is WT80. So you can say that this is the entire present value of lifetime consumption. This is the present value of lifetime consumption. This is the consumption value of consumption. This is the value of consumption for the present period, right, and future period. This is the value of consumption in future period, because this is 2T plus 1 future period, and this is the value of consumption for the present period. And this is the total labor income or lifetime labor income. So the sum of value of consumption in future period plus value of consumption in present period equals to lifetime labor income. So that is being established here. Now I want to give it a name. I want to give this equation a name of number 2, suppose, and this equation which I wrote it earlier, this equation, right? So this equation will be given the name of number 1. This utility function that I have written is number 1, and this is the second equation. This is basically our budget constant. Now we want to maximize this first equation with respect to second. Maximize this first equation with respect to second. So basically we are going to maximize it, and at first we are going to use the Lagrangian method. For that, let me write L equals to C1T to the power 1 minus theta by 1 minus theta plus 1 by 1 plus rho multiplied by C2T 1 minus theta divided by 1 minus theta. This is our utility function, as you can remember, and we have to set up the Lagrangian, and we have to give the budget constant. What is our budget constant? This is our budget constant. We will take basically we are going to take these sides, these two parts, or these two terms of the equation on the right hand side and take the budget constant. So and write it as WT80, or you may write 80WT, both are same things basically, minus within a bracket I may write C1T, or if you I don't want to keep minus bracket, that is also okay. C1T minus 1, it was plus there, but due to this minus it is being converted into minus 1 plus RT plus 1 into C2T plus 1. Okay, so this is how it is working now. It is very easy, and I want to multiply, I want to take this Lagrangian function, and I want to differentiate this Lagrangian function with respect to C1T once and then C2T. So if I differentiate this Lagrangian function with respect to C1T at first, you can see that only this portion is having C1T, right, and we have this portion having C1T, this portion. So this portion, when we try to differentiate it, at first we have to take the 1 by 1 minus theta out of the differentiation because it is the constant term. Then we have to differentiate this C1T to the power 1 minus theta. So obviously the power will come out as 1 minus theta, and then we may write C1T, and 1 minus theta will be subtracted with minus 1. So that's how it works. We know the differentiation of x to the power n is nx to the power n minus 1. I mean, you obviously know this. So by that method we have applied here. Now the question is that is covered. Now if I want to differentiate the C1T, it is obviously multiplied with lambda, and lambda will be taken out as constant, and we will differentiate only c to the power on C1T, and it is minus C1T, so we will have only minus 1, and lambda is taken out as constant, so lambda multiplied by minus 1, that will be the result of derivative. It is equal to 0. We are setting up the first order condition equals to 0. So now it becomes basically it becomes 1 by theta will be opted out, and we will have this minus 1 and plus 1 will also not be there, so we will have only C1T to the power minus theta equals to, this is minus lambda basically, and this minus lambda, when it is going on the right hand side and we are taking it on the right hand side, it is basically become plus lambda. So this is our third equation that we are going to name, and let us take the Lagrangian function again, and we are going to derivative differentiate it with respect to C2T, or the second C2T plus 1 basically. So with the second period consumption basically. So when you do it, C2T plus 1 is basically here we have C2T plus 1. So now the question is, C2T plus 1 is having in this portion, and it also being consisted in this portion. Now if we differentiate it, what happens? Let me clean it at first. So for this portion we will take 1 by 1 plus rho and 1 by 1 minus theta out of the differentiation or out of the derivative part, because it is constant, and we will do the differentiation or derivative of only C2T to the power 1 minus theta. So now if I do it, at first let me take the 1 by 1 plus rho multiplied by probably we are multiplying it by 1 by 1 minus theta. This is being taken out of the derivative part, and we will do the derivative of only C2T to the power 1 minus theta, this part only. So if we do the derivative of C2T to the power 1 minus theta, what do we get? We get at first 1 minus theta will be coming outside, and we will have C2T, and we have 1 minus theta minus 1. And for this part, for the this part where we have c to the plus 1, and we have also 1 by 1 plus r t plus 1, so that 1 by 1 plus r t plus 1 will be taken out of the differentiation, and lambda that will also be taken out of the differentiation or derivative we will only do the derivative of c 2t plus 1. So that will be equal to 1. If we do the derivative of c 2t plus 1 with respect to c 2t plus 1, 2t plus 1, then we will get 1. So now we will get only lambda into 1 plus rt plus 1, and we will have a minus sign because this has minus sign, but anything else we are not getting anything else here. So we are getting lambda into 1 plus rt plus 1, and we have a minus sign, lambda into 1 by 1 plus r t plus 1. So that's what we have. Now this is our basically I will set up it equals to 0, and we will cut this out. We will have only 1 by 1 plus rho into c 2t, and here 1 and 1 will be opted out. We will have only minus theta, and this part if we take on the right hand side, it becomes positive again, lambda by 1 plus r t plus 1. Now in the first in the third equation, in the third equation, as you can see, I have set up that c1t to the power minus theta has been equal to lambda. So basically I can write c1t to the power minus theta in place of lambda. Both are equal. So I may write this as 1 by 1 plus rho into c 2t plus 1 to the power minus theta equals to, in place of lambda I am going to write c1t to the power minus theta by 1 plus r2t plus rt plus 1. Right, now the question is, let me erase it and write it properly. Now the question is that if I take this into this part in the left hand side, then what becomes c 2t plus 1 to the power minus theta by c 1t minus theta. And if we take this 1 plus rho, probably yes, if we take this 1 plus rho on if I take this 1 plus rho on the right hand side, so it becomes 1 plus rho divided by 1 plus r t plus 1. So now the question is that if I just convert this, and now if I want to convert this to the power minus thetas into to the power plus thetas, then I may take this c1 to t to the power minus theta in the numerator and c2 t plus 1 to the power minus theta in the denominator. Then their signs of their powers will be converted as positive. We all know that 1 by x to the power minus 1 is nothing but x to the power plus 1. Similarly, suppose you have x to the power minus 1, then that will be equal to 1 by x to the power plus 1, or only 1 by x. So that is very easy. Now if I do this, then it becomes c to the power 1t plus theta divided by c to the power 1t, c to the power 2t plus 1 plus theta. And yes, this is what it is. And we have on the right hand side, we have 1 plus rho divided by 1 plus rt plus 1. Now the question is, if we want to consider this, and then I can put it on the right hand side, and I want to check, I want to find out the value of c 2t plus 1 to the power theta. I want to check that value, that what it actually comes. Then for that I may write that if I take this on the right hand side, and I may write c 2t plus 1 to the power theta equals to, this part will then come to the numerator and this part will go to the denominator of the left hand side. So I hope you are understanding it. 1 plus rt plus 1 is going to the numerator, and 1 plus rho is going to the denominator, and we have c1t theta, obviously we have it on the numerator portion, c1t to the power theta. Now from this we can understand this. From this we can easily get the idea of that basically if this portion, this rt plus 1, if it is greater than this row, then this fraction will be a greater fraction, and in that case obviously if this, and then I mean to say if rt plus 1 is greater than rho, let me write it. If rt plus 1 is greater than rho, then 1 plus rt plus 1 by 1 plus rho, this will be greater than 1. Obviously if this is greater than rho, rt plus 1 is greater than rho, then this fraction will be greater than 1. And in that case ct2 plus 1 theta, or this portion, will be greater than c1t theta, because for equating both the equations, for equating c2t plus 1 to the power theta with c1t to the power theta, we have to multiply something, some positive number which is greater than 1 with c1t to the power theta. So obviously ct2 plus c2t plus 1 to the power theta is greater than c1t theta to the power theta. So here for that I can write c2t plus 1 to the power theta is greater than c1t to the power theta. Okay, and similarly, if that, obviously what is the implication of? The implication of this is the future consumption will be greater. The implication of this is that the future consumption will be greater. Similarly you can do the vice versa also. If rho is greater than rt plus 1, then the current consumption is greater. I am not going to explain it because it is just the vice versa of the previous one. So in that case the current consumption is greater. Now the concept is very clear, I feel. So if I want to write this budget constant again, I feel you can remember what is which one is the budget constant. This equation that we have written here, let me show it again. This equation that we have written here, it is the budget constant. Okay, so if I write this budget constant again, that is c1t plus 1 by 1 plus rt plus 1, that is the discount, into c2t plus 1, it is the consumption in the present period, consumption in the second or future period being discounted, and we have equals to WT80. WT80 is nothing but the total labor income, or the entire labor income of the entire life period. Now we know the value of c2t plus 1 now, right? So what is the value of c2t plus 1? We know that the c2t plus 1, the value of c2t plus 1 is determined here, and it is the value of c2t plus 1 to the power theta. Now here we need the value of c2t plus 1 to the power only c2t plus 1. We don't need this theta. So we can do a simple operation for that. We have to take the power of let me show it you. So you can do this like this. If we take the power or exponential of c2t plus 1 to the power theta, and if we take the exponential of 1 by theta, then this theta and this theta will be opted out, and we will get the value of c2t plus 1. So we will have to convert this, and we have to take the exponential in both the sides. Both the sides mean we have to take the exponential sorry, this is also theta, and we have to take the exponential of this portion also. So this theta and this theta will be opted out, and we have to actually take the exponential of both. So just it will be 1 by theta in this portion and 1 by theta, and it has theta as power. So it will be opted out. This will be opted out. We will have the value of c2t plus 1 equals to 1 plus rt plus 1 by 1 plus rho to the power 1 by theta. Now The value of c to t plus 1 is nothing but, we have determined the value of c to t plus 1 as it is equals to, as you can see from here, where it is, right, it is here, 1 plus rt plus 1 by 1 plus rho to the power 1 by theta multiplied by c1t. So 1 plus rt plus 1 divided by 1 plus rho to the power 1 by theta multiplied by c1t, and this will be equal to wt18. Now if you do a simple calculation on this and just do the addition, just do the simple addition, I mean to say, then what will be the LCM? If I want to determine the LCM of this portion, then you can easily determine the LCM of this portion. Then for that I may say that take this part in the numerator, and then we will think about the LCM on other calculation. So if I take this part in the numerator in this portion, then what happens? I may write it as c1t plus, now this part in the LCM numerator means it will be 1 plus rt plus 1 to the power minus 1. So it will be 1 plus rt plus 1 to the power minus 1, and we have something else that is called 1 plus rt plus 1 by 1 plus rho to the power 1 by theta. 1 plus rt plus 1 divided by 1 plus rho to the power minus theta. We have it, right? And to the power 1 by theta, 1 by theta. And we have it multiplied with c1t, so you can write c1t, that is equals to 80 wt. Now the question is, if I just multiply these two portion, then what actually happens? Well, to be honest, I may just write it as c1t by 1 plus rt plus 1, bases are equal, 1 plus rt plus 1, 1 plus rt plus 1, so the powers will be added. So that is 1 by theta minus 1, and this 1 plus rho, it has also this 1 by theta as power, as exponential, so I have to give it also 1 plus rho to the power 1 by theta equals to 80, oh sorry, we have mistaken the c1t here, c1t, and that will be equal to our 80 wt, the total labor income, 80 wt, let me write it here also, 80 wt. Now if I take the LCM, then the LCM, and if I want to do the addition, then at first I have to take the LCM. So the LCM will be obviously 1 plus rho to the power 1 by theta. So I may write the LCM as 1 plus rho to the power 1 by theta. And okay, c1t will be multiplied with it. I know you know the basic addition, all of you know it. So 1 plus rho to the power 1 by theta will be multiplied with c1t, and 1 plus rt plus 1 to the power 1 by theta minus 1, this will be nothing but 1 minus theta by theta. If we do the calculation, it will be 1 minus theta by theta. So I may write it as 1 plus r t plus 1 to the power 1 minus theta by theta, and in the right hand side we have 80 wt. Now the concept is very clear here, that 80, we know that, if we take 80 and wt is the fixed income, it is the labor income which is the fixed income, total lifetime labor income, if we take it as fixed income, as constant value, and if we take theta equals to 1, if we let theta equals to 1, and if we let that rho is very less, the value of rho is very less, that means it is negligible. If we take these three things, then RT plus 1 is the only determinant of the fraction of income that individual is going to consume in first period. Okay, how much fraction of income the individual is going to consume in the first period will be determined by only this RT plus 1 then, because the other factors, rho, we have considered theta equals to 1, rho is very less, ATWT is fixed income, rho is very less, theta is negligible. So the C1T, this is only determined by RT plus 1. Okay, so I think I have made it clear. So I can write it as, it is interest rate, it is interest rate RT plus 1 that determines C1T. I hope it is clear. Now we are going to see the income effect and substitution effect. For that, I will take this portion, this equation again. Now if you see this equation properly, if you observe this equation properly, then observe this equation, 1 plus RT plus 1 to the power 1 by theta, this part of the equation. Okay, I think further more modification is required here so that you can understand it. I have actually forgotten to do a modification. Let me modify it a bit, then you will get better understanding of it. Here we have C1T also, that was here. If I take C1T common out of it, then what do we have? Then we have 1 plus rho to the power 1 by theta, I am taking a third bracket, plus 1 plus r t plus 1 by 1 minus theta by theta equals to ATWT, and we have in the denominator part we have this called 1 plus rho to the power 1 by theta. If I multiply this 1 plus rho to the power 1 by theta on the right hand side and then divide this entire part, 1 plus rho to the power 1 by theta plus 1 plus r t plus 1 by 1 plus t plus 1 to the power 1 by theta by theta on the right hand side, then what actually is the value of C1T will be remaining only on the left hand side. So the value of C1T will be equal to, at first I am going to multiply this 1 plus rho to the power 1 by theta with AT and into WT. So AT into WT is now becoming, so AT into WT, and with AT into WT we are going to multiply 1 plus rho to the power 1 by theta, and obviously on the next portion this part will be divided. That means 1 plus rho to the power 1 by theta plus 1 plus RT plus 1 to the power 1 minus theta by theta. This part will be divided. So we have 1 plus rho to the power 1 by theta plus 1 plus RT plus 1 to the power 1 minus theta by theta. Okay, now you can see that C1T is actually being determined by only this RT plus 1. If we take that theta equals to 1, rho is very negligible, ATWT is fixed. If we take these criteria, ATWT is fixed or constant, and theta equals to 1, rho is very less, rho equals to very less, that means negligible, then C1T, current period consumption, is being only determined by RT plus 1. I hope it is very much clear now. And if we take this, and I am going to illustrate this income effect and substitution effect with the help of this also. Let me erase it. So now this portion, concentrate on this portion, 1 plus RT plus 1 to the power 1 minus theta by theta, concentrate on this portion. So now if this portion is increasing, if I mean to say, I can say that if R is increasing, RT plus 1 is increasing, then obviously this value, this entire value will increase, right? This entire value will increase, and this entire fraction will decrease. This entire fraction will decrease. That means this entire fraction is nothing but the value of C1t. So that means C1t will decrease. Right. So when R increases or RT plus 1 is actually increasing, we have the C1t falling. So a rise in R is nothing but the rise in the rate of interest. And when rate of interest increases, what happens? When rate of interest increases, we all know that we are going to keep our money in our banks, not in our hand. So we are going to keep the money in our banks, and we are willing to do savings. So in the first period or in the present period, we are doing savings or we are consuming less. That's why C1t is falling. And in the second period or in the future period, we are going to consume more, because we are going to dissave whatever we have saved. We are going to dissave it. So that's how when R increases, the value of C1t falls, as we are going to save the money. Current period consumption falls as we are going to save the money. This is nothing but substitution effect. So if I write the substitution effect, what is substitution effect? When R increases, C1t actually falls as we are saving our money for the future period. And in the future period, we are going to use that money. We are saving our money for the future period, and in the future period we are going to use that money. And that's why in the future period we are going to use that money. Future period. So when we are going to use that money in the future period, that means future consumption, that is C2t plus 1, that will increase. So that means the consumption of the C1t is being substituted with the consumption of C2t plus 1. This is known as substitution effect. And I am going to talk about the income effect a little bit now. Income effect. Now income effect. What is income effect? When R increases, we are keeping the money in our bank. That is okay. Absolutely okay. Basically, savings in first period is less than consumption in the first period, because whenever R increases, more saving in first period. We are doing more saving in the first period and less consumption in the first period. So when R increases, that means more saving, less consumption in first period. Okay. And obviously second period consumption will again decrease the savings. We all know it, that second period consumption, we are going to use that saving as our consumption expenditure. So second period consumption will decrease our saving, will give a fall in our saving. I hope it is clear. Now the concept is here that both period consumption will slightly increase. Economists give the theory in this, that both periods consumption of the present and consumption of the future, or consumption of the current period and consumption of the future period, both periods consumption will actually slightly increase, and the consumer will feel richer. Suppose I have 10 lakh rupees in my bank account and I am saving it. I will obviously feel richer. I will feel that I have that amount of savings in my bank. I am richer. So this effect of feeling richer is known as income effect. And here the value of theta is very important. If the value of theta in this equation, let me show. If the value of theta, this is the value of theta, or you may say, right, probably I am not dealing with the right equation. Right here, this value of theta, you can see this value of theta, or you may say this value of theta or this value of theta. This value of theta is very important. If theta is low, that means the value of theta is smaller, very much smaller. Then we have to know that substitution effect is dominating. Substitution effect is dominating. And if theta is high, then income effect is dominating. If you Still not being able to understand this, then comment me, I will make another video on this. Dominates.